Let's learn how to control multiple LEDs using Arduino's digital outputs and a breadboard. We'll connect some LEDs to the Arduino Uno and compose a simple program to light them up in a pattern. Take a look at the work plane, where I'll add a breadboard from the Components panel. The rows of a solderless breadboard are connected inside, allowing you to connect components by plugging them into the same row as each other. The special long rails along the edges are for easy access to power and ground. It's a best practice to always connect 5 volts and ground to these long rails as a starting point for any Arduino circuit. Try it for yourself in Tinkercad circuits. Double-click along a wire to create bends you can use to tidy up your circuit. To change your wire colors, select the color in the inspector or use the number keys on your keyboard to quickly switch between colors. Wire connections to 5 volts are typically red, and those connected to ground are typically black. Let's recreate the blink circuit using the breadboard. Add an LED to the breadboard so its legs go into 2 different rows. If your breadboard's up and down, you can use the rotate tool. Attach wires to any of the holes in the same row to make an electrical connection. Just like before, we want to connect the LED and resistor in series to pin 13 and ground. This breadboard circuit is electrically identical to this free-wired circuit. You can build either way in the editor, but if you're also building a circuit with physical components, the breadboard will help keep your virtual circuit looking the same. Let's add a few more LEDs to this circuit along with their companion resistors. For each, connect one end to ground, in this case through the resistor, and the other end to a different digital output pin on the Arduino board. Let's use the code blocks editor to create this animation effect. To make the speed of the animation adjustable, add in a variable that will serve as the amount of time between state changes. I'm going to call mine animation speed. At the beginning of the program, set the variable to your desired time in milliseconds. Drag the new variable onto the wait block to set it to whatever animation speed is set to. Don't forget to do the drop down for milliseconds. Use another output block to set the next pin, 12, high, then low, with a pause after each. Duplicate this block for as many LEDs as you have left, and change the pin numbers to correspond to the connected LEDs. Test out your code by starting the simulator. In the text editor, you can see the Arduino code generated by the code blocks. Before the setup, we can see our variable is created. It's called int because it's an integer, or any whole number. Inside the setup, just like last time, the pins are configured to be outputs rather than inputs using the pin mode function. The code inside the loop looks familiar too, using digital write to set pins high and low, on and off, and pausing in between for a number of milliseconds. And see, because we created the variable animation speed, if we change that number once at the start of the program, it will affect all of the places in that program that reference it. So in this case, changing the variable animation speed will control the pauses and therefore the overall speed of the animation. You can wire up your physical Arduino Uno to look like the simulated one, and then copy the code from the window and paste it into an empty Arduino sketch, or click Download Code and open the resulting file in your Arduino software. Notice how Tinkercad circuits will highlight the connected pins when you hover over a row. And you could also refer back to this photo of the breadboards inside. You'll get plenty of breadboard practice in the upcoming lessons and become a pro prototyper in no time. Now that you've learned to use a breadboard and code for digital outputs, you're ready to try even more fun stuff. Try learning to fade an LED using analog write, or skip ahead to learn to detect inputs and push buttons with digital read. Thanks for watching and learning with Tinkercad circuits. Check out the rest of our huge collection of interactive beginner electronics tutorials and even build circuits into your 3D designs. See you next time.